This is Chapter 2.4, Quick Review, Problems 1 through 10, page 223. And this section of the book is about finding real zeros of polynomial functions. So really in these exercises, we're kind of going to develop our skill, some standard skill in being able to do so. So what you're doing, we're going to look at odd-number problems, exercise 1 for rewrite the expressions in polynomial standard form. Here we have a cubic trinomial in the numerator and divided by x. And so what we have essentially is we can separate and just take each term and divide by x individually. So we have x cubed over x minus 4x squared over x and plus 7x over x. And what we have here is we have x cubed over x, which is like x to the third power divided by x to the first power. That's rules of exponents. That's going to end up being x squared. And then we have minus 4, and we have x squared divided by x. That would be x times x over x. So we have just x. And the last term here we have is plus 7, and x over x cancel. And so our answer is going to be right here. The quadratic trinomial, x squared minus 4x plus 7. Next odd-number problem. Here we have 3. Now, one thing about standard form is we need to go ahead and put our terms in descending power order. So as we work out this one, I'm going to rewrite. I'm going to put the highest power term, 7x to the 5th. So I'm going to make that first, 7x to the 5th divided by x squared. And then we're going to have our next highest term is going to be x to the 4th. So that's going to be plus x to the 4th. There's no sign to the left of that x to the 4th, meaning that that's going to be plus x to the 4th over x squared. And then minus 3x squared over x squared. And what we have here is, to work it out, we have x to the 5th divided by x squared. That's going to be 5 minus 2 is 3, so we're going to have 7x cubed. And plus x to the 4th divided by x to the 2nd, that's going to be plus x squared. And we're going to have minus 3, and x squared over x squared cancel equal 1. So we have this cubic trinomial, 7x cubed plus x squared minus 1. Next odd-number problem. In exercise 5 through 10, factor the polynomial into linear factors. Here we have a cubic binomial, but we want to put this in linear factors. So what we do, our principle we look for first, is what we call the greatest common factor, GCF sometimes. Okay, so GCF. So anyway, our greatest common factor, I'm going to write this to the left here, x cubed minus 4x. Well, x is the common factor for both of those. And we're going to have left, what times x equals x cubed? Well, that's going to be x squared. What times x is going to be negative 4x? So that's going to be minus 4. And so now we have something called the difference of squares. Factoring using difference of squares, we're going to use that. Okay, that's going to be, we're going to factor this binomial here, this quadratic binomial. So we still have x, And we take the square root of x squared, which is x, for each of these binomials, and instead of minus, we put plus minus here, and we take the square root of that second term, that last term, which is 4, so that's going to be 2. So here we have linear factors, 1, 2, 3 linear factors, completely factored. X is a linear factor, quantity x plus 2 is a linear factor, and quantity x minus 2, they're all linear factors. Next on our problem 7. Okay, we have 4x squared plus 8x minus 60. So what is our greatest common factor? We don't have an x here, do we, that's involved? Well, 4 is a factor here of this one on the left, right? 4x squared, that's obvious. And then 8, well, 4 times 2 is 8, that's right. So 4 times 6, 4 times 15 equals 60. So 4 is going to be our greatest common factor. And we put x squared. And let's see, it's going to be 4 times what equals 8x? Well, that's going to be 2x, right? And then 4 times what equals negative 60? Well, 4 times 15. And so we have a quadratic trinomial, and there are different ways to look at factoring this. I'll just draw a box. That's what I do when I start out. I sort of forgot how to factor. Okay, first term goes in the upper left, so that's going to be x squared. Last term goes in the lower right, minus 15. And x and x are going to be your factors of x squared. That's easy. So x, I'll write this. So x and x. So what two numbers do you multiply together to equal 15 that when you subtract them will equal 2, right? Well, 5 and 3. And we're going to have minus 5. Let's drop and do it wrong first. Minus 5, 3. So 3 times x is 3x. And negative 5 times x is negative 5x. And if we if we add these together, we're going to get negative 2x. Is that right? No, we need the positive 2x. So we're just going to back up here. And we're just going to make this plus 5 and minus 3. So we have 5x here in the upper right and minus 3x in the lower left. See, that's going to work for us this time, isn't it? So our factors are going to be 20x plus 5 times 20x minus 3. And if we wanted to, these are linear factors. Let's just keep the 4 out there. We could put the 4 back in there with the x and multiply the 4 times by the 5 there, but we'll just leave it like this. 2 linear factors. Next, last under problem is 9. Factor the polynomial into linear factors. Well, this one is a little more complicated because we have 4 terms in here, and you can try factoring by grouping. What you're going to have here is your possible factors, rational roots theorem. You're going to have 3 things here. You're going to have, you could have the negative 2, which is the last term over the first term, the coefficient of the first term. So you could have, so our possible factors are going to be x minus 1 x plus 1, x minus 2, x plus 2. So that's kind of like a list of possible factors. But let's go ahead and, if we just say x minus 1, we will say that we're kind of getting into polynomial long division. Okay, try x plus 1. X cubed plus 2x squared minus x minus 2. So here we have x cubed divided by x, we have x squared, and then x squared times x is x cubed. Then, let's see, x squared times 1, x squared. And we subtract out, we get x squared. And then we have, to bring down this minus x. We have here is x squared divided by x is x. X times x is x squared. X times 1 is x. So if we subtract out, we get 0. Negative x minus x will be minus 2x. X, negative 2x divided by x is minus 2. 2 times x is negative 2 times x is negative 2x. I think this is going to work out. And I forgot to bring down this minus 2, right? And negative 2 times 1 is negative 2. So we have no remainder. So this is a fact. So there we have a factor. So I'm going to write the factors down here. We have x plus 1. And we have x squared plus x minus 2. And so we're going to have, for this thing right here, x squared plus x minus 2, we have x and x. And your factors of negative 2 are going to be plus 2 minus 1. Because if we just go like this, if we put in x plus 2, x minus 1, where I'm looking at these last two terms, we get x squared plus 2x minus x, and we're going to have minus 2. So 2x minus x, that's going to be just x. So if we divided by x plus 1, but we also would have been able to divide by x minus 1. So these factors here, these three that I'm circling in red, are the ones they turned out to be from our list of possible factors. We have x plus 2. So the only one that we could have used that would have taken us down a wrong path is to divide by this x minus 2. So it's kind of a prelude in a way to what we're doing later this chapter 2.4, polynomial long division. Anyway, good luck on your even number problems, and I thank you for viewing.